Okay, in this video we're going to continue on by looking at the future value of annuities. The formula is here. I'm not particularly interested in the formula. You can see that in the textbook and here. Let's look at an example. If we put in $2,500 every 6 months at a rate of 7.76%, how much will you have in 30 years? So we've got cash flows happening every 6 months. Our periods are 6-month periods. Our periodic rate then is going to be 7.76 divided by 2, and that's where we get this 3.88%. The number of periods is going to be 60. 30 years times 2 periods per year will give us 60 periods. And plugging everything into the formula, we get 568,014.89. If we move on to the calculator, Excel and then the calculator. With Excel we use the future value function. Now we'll have some periodic payments inputs. So the inputs will be 0.0776 divided by 2, 30 times 2, and then negative 2,500. We don't need to put in the lump sum. There is no lump sum. We could put a comma and a 0, but we don't need that argument. And then the same thing for the type. Stick that stuff in, we get 568,014.89. With the calculator, just put in all those inputs and we get the right answer again. So let's look at each of those. Let's do it in Excel, and then we'll use the financial calculator and then move on. So the future value of annuities over here, we can just hard code in the pieces of the formula just like we had on the slide. Type all that stuff in, we get the right answer. Oh, by the way, I did put in negative 2,500, the cash flow, or the sign of the cash flow, to indicate that we're investing that $2,500 every period. And so our result is a positive 568,000 that we would have in our account balance. That's how much we would have to be using. The alternative way to kind of show everything is to spell out the present value, future value, all these inputs. I put all those in. These are calculations, so it's not just a hard-coded number, but it's a calculation for that input. Same for the number of periods. I just refer to all the cells here, and again I get the correct answer. With the financial calculator, let's go to clear all my inputs here. And for the N, I'm going to put in 60 the other way. 30 times 2 is the N. 7.76 divided by 2 equals, and then I'll put that in for the periodic interest rate. We're solving for the future value, so we need to put in a present value of 0. The payment is $2,500 negative, and then we're going to compute the future value, and we get 568,014.89. So very straightforward, very simple calculations. Let's move on in the slideshow to pricing of a bond. So because a bond has both periodic cash flows and a lump sum payment, it is simply the sum of those two present values. So we got this kind of cumbersome formula. So we've got it on the left side, it's the formula for an annuity, the present value of an annuity, and then the second piece is the present value of a future cash flow, that principal repayment. We're calling it F for face value perhaps. So we add those two pieces together and we get the price of a bond. So as an example, what is the price of a bond that has a coupon payments of $33 every 6 months? If the interest rate is 6.76%, and it matures in 6 years. So plugging all the pieces into the formula, we need to get the periodic rate. So that's going to be 6.76% divided that by 2. That would give us the 3.38% down here. 6 years is going to be 12 periods, 12 half-year periods. So those are all the inputs. We stick those into the formula. We're careful to have all of our parentheses in order of operations, and we get these two pieces. The 321.15 is the present value of all of the coupon payments. The 671 is the present value of the lump sum payment at the end, the repayment of the principal. Add those two together, and 992.21 is going to be the price of my bond, the value of that bond. Let's look at it in Excel and with a financial calculator, how we would do that. This is very easy, of course, using Excel and a financial calculator. So that's why I prefer much rather do these things with our tools than with the formulas. So again, what is the price of a bond with these inputs? We use the PV function. Need to get my periodic rates, the number of periods, the payment. The periodic payment is 33. That's going to happen every 6 months. Then my lump sum is 1,000, and I solve for it, and I'm going to get a result that's a negative 992.21. That just indicates that I would need to pay that amount of money for this bond in order to receive those future cash flows, the series of 33s, and then $1,000 at the end. With the financial calculator, the same kind of inputs. We just need to be careful. Oh, I just saw a mistake here. This is not going to be 0.0676. It'll be 6.76 divided by 2. So remember, we have that distinction between how calculators work and how Excel works. So let's move on to the examples here. First, in Excel, we're finding the price of a bond. We can hard code all of the inputs. 6.76 divided by 2, etc., etc. We get 992.21. Or we could spell them all out here. The things to pay attention to are, I'm doing this calculation of the periodic rate within Excel. I'm not doing it by hand. Oops. Then I'm referring to that cell in my calculation. So even though, well, this is a very straightforward calculation. If this showed less than 4 decimal places, all of that information would still be contained within this cell. And my calculation, because it refers to that cell, would be very accurate. So we want to capture all the information. I don't want to be rounding things. It would be inappropriate to just type in 3 or 3.4 here. Let's do the calculation within the cell and then refer to the cell to get the exact right answer. In a calculator, again, this is going to be very straightforward. The number of periods is 12. The periodic interest rate, 6.76 divided by 2. Equals, that's the rate. The payments are 33. The future value is 1,000. Compute the present value, 992.21. All right, let's move on and take a look at some default settings for bonds. So these are some assumptions I want you to have in mind every time you think of a bond, and anything that changes these I will very clearly spell out. So for instance, bonds will always have $1,000 face value unless you're told otherwise. And that's irrespective of this fact here that prices of bonds are typically reported in percents of par. So you might see a bond that's 101 or 105 or 92. That's a percentage of par. So in this example, if a bond was priced at 11.55, you might also see that reported as 115.5. So 115.5% of par. Those are equivalent ways to express it, but our bond is always going to have $1,000 face value unless you're told otherwise. Likewise, bonds will always pay interest on a semi-annual basis. So the default is 2 periods per year. Again, I may say that a bond pays interest annually, or I could even say a bond pays interest quarterly. That would change this default setting, but in the absence of any other information, a bond is always going to be paying interest semi-annually. And this, by the way, includes zero coupon bonds. So even though it's not paying a cash flow, the default setting is going to still be 2 periods per year when you're doing your yield to maturity calculations, for instance, or pricing calculations for that matter. 2 periods per year is the default setting. Rates, anytime you see a rate, it's going to be stated in annual terms as the default. So if you see 6.76%, that is an annual rate, and then you would need to go in and adjust that to correspond to the periodic rate you need for your calculations. So I'm never going to tell you a quarterly rate, for instance, unless it specifies quarterly rate. So don't interpret, for instance, 2.79% as a quarterly rate or a monthly rate unless it very explicitly says that in the problem. Any rate you see is an annual rate, and you need to adjust that unless, again, it's specified as something else, something other. Bonds are going to be option free. That's the default setting. So not callable, not puttable, not convertible, again, unless it's stated otherwise. And then finally, and I kind of touched on this a minute ago, you don't want to round any of your calculations until the final answer. And in your final answer, I want you to show at least to the 100th of a percent, e.g., for example, 13.79%. I wouldn't want to see 14% as the answer or 13.8%. For your dollar amounts, you can round to the nearest cent. Use your judgment. I mean, sometimes I'll specify rounding to the nearest dollar is typically fine if we're talking about millions of dollars. I don't need to worry about the pennies at that point. So those are our default settings, and let's move on in the next video to bond pricing examples. I'm going to go ahead and stop here, and we'll pick up in the next video with looking at some further examples of bond pricing. So I will see you then.